Okay, so what I was saying is this, here, like we have something like this now. What are we supposed to do for us to find the values of x? First of all, you need to make this number be part of this. And how are we going to combine it? We are going to come up with something like this. Plus 1 over x minus 2, and you say minus 3 less than or equal to 0. What you're going to understand, you find the common denominator first of all. So the common denominator we are going to get is this one, because I know that if I say this into that, I'll get the same. I'll get 1 multiplied by the numerator. I'll have x plus 1, say minus this. This into that, we're going to get this one. If you multiply this by that, we're going to get negative 3 open x minus 2, something like that. Yes, less than or equal to 0. All right. So if you proceed, what you're going to understand is we're going to have x plus 1 minus 3x. This multiplied by that, we're going to get plus 6 over x minus 2 less than or equal to 0. Okay, so if you say x minus 3x, what answer are you going to get? We are going to get negative 2x. If you add this plus that one, you're going to get 7 over x minus 2 less than or equal to 0. This is where now we have to find the critical points. How do you find the critical points? You have to make sure that what is on the part of the numerator, you equate it to 0, and also this one, you equate it to 0. But be careful. If you are finding the solutions, like you want to get the domain, the range, whichever, you have to make sure that this one is going to be ignored as part of the solutions. Hence, its bubble is going to be unshaded. And you're going to use smooth bracket for this one. So you have to say negative 2x plus 7 equal to 0, comma, x minus 2 has to be equal to 0 as well. So if you take this to the other side, we are going to get negative 2x equal to negative 7. You divide by negative 2, divide by negative 2. We're going to get x equal to 7 over 2. Then for this one, you just say x has to be equal to 0 plus 2. We're going to get the other value of x as 2. So if you try to divide here, you're going to get something like maybe 3.5 if I'm not mistaken. By the way, here, no use of calculator in mathematics. No use of a calculator in mathematics. All the numbers that are in a form of a fraction, you leave them like the way they are. You don't proceed. Once you find the denominator, the decimal places, someone is going to even start thinking to say this guy used a calculator. All right, so here we have now to focus on this other part. I have to focus on this other part. So for this one, we have two different critical points. We have x is equal to 2, comma, x is equal to 7 over 2. This is the first set of critical points, and I'll use these same values to write them on my sign graph. I think by this time around we understand what a sign graph is. What it is now, we focus on this part. We are having negative x minus x. Remember, if you are multiplying something which is having a denominator, or rather in a form of a fraction, you only multiply with the numerator, not the denominator, no. So here, we are going to find the common denominator for x minus, negative x minus 1 over x minus 2 minus 3 over 1. So you say over, if you find the common denominator here, what answer are you going to get? We're going to have x minus 2 as our common denominator. So if you say this into that, we're going to get 1. Multiply by that, we're going to get negative x minus. So here you say minus 3. This into that, we are going to have this. This multiplied by what is on top, definitely we are going to have x minus 2 less than or equal to 0. So on top, we are having negative x minus 1. If you multiply this and that, we're going to have negative 3x plus this and that, we're going to have 6 over x minus 2 Then this plus that, we're going to get negative 4x. Negative 1 plus 6, we're going to get positive 5. So we're going to have x over minus 2 less than or equal to 0. You find the critical points also for this part. We're going to have negative 4x plus 5 equated to 0. And we're going to have negative 4x equal to negative 5, negative 4, negative 4. You cancel this, x is going to be equal to 5 over 4. That is the first value on the second set. You go to this remaining part. Here you just say x minus 2 has to be equal to 0 and x is going to be equal to 2. So meaning that we are going to formulate two different sign graphs. We are going to have two different sign graphs. They are going to give us certain things that are common. Then we are going to combine them using the method I'm going to teach you right now. Now, focus on this part now. We have our critical points. The first set, I'll say set 1. The first part of our critical points, we are saying x is equal to 7 over 2, comma x is equal to 2. So I'll draw a sign graph. How am I going to draw a sign graph? Remember what I said last time for those that were there? Okay, pam pam. We're going to have another one. Oh, this one has to be complete. It is not complete. Pa. Then the other one. Pa. And the last line is going to be for the overall sign. So we're going to have 3 different vertical lines and also the last one. Remember the symbol we are using. That's why I told you to say do not divide by a negative, because you are going to change the symbol we are using. Here we are using less than or equal to 0. Always the denominator shouldn't be part of your solutions when writing the so-called domain and the like. What I mean is this one, since if you say x is equal to this, meaning that you are saying x is also part, 2 is part of your solutions. So if you try to take this, you replace it here. If you take 2, you try to replace it at this given part, automatically we're going to get 0, meaning that the entire function is going to be undefined. So we are trying to make this one, when writing the domain, to make it like maybe it is not part of the solutions by using smooth bracket. Why? Because for the ones that are part of the solutions, we are using square brackets, close brackets, shaded bubbles, and also less than or equal to, including greater than or equal to. In this case, we only have the numerator, which is going to carry a shaded bubble, and also this, or rather that. Why? Because denominator won't be considered to be part of your solutions once you're writing for the so-called range. All right. Which one has to start first? This one or that one? 2 has to come before this one. 7 over 2. Remember, all the numbers in between, here you can just say 2 has to be less than the number which is in between, which is x, and then at the same time, x must be less than 7 over 2. Why do I write like this? It's because I'm trying to choose the numbers that are going to be between these two. And also you have to pick a number which is going to be before 2. You say x must be less than 2. Here you pick a number which is going to be above that one. That's why we write it like this. X must be greater than 7 over 2. You write the same to my expressions that you have. Get back to what you are from getting. Here we are going to have 2 different factors. These are what we call factors. Before you even equate them to 0, we call them factors. This and what is on top. So here I'll start by writing this one. I'll say negative 2x plus 7. On the first, can row, can column, I don't know. But this one stands in both. It can either be a row and also part of the column. So we're going to have negative 2 plus 7. Down here we're going to have negative, x minus 2. The reason why we're trying to So if you try to get a number which is before 2, you can just pick 0, meaning that you are going to take this 0 and place where there is x. If you say 2 multiplied by 0, since you've picked a 0 here, you can even pick -1. You're going to get the same answer. So suppose you get a 0 on this part, you want to use 0 in the middle. Since we are saying this is 3.5, meaning that the number between 2 and 3.5 can be 3. Then on this other side, if you want, you can even pick 4, because 4 is above 3.5. Why do I pick these numbers? Are the ones that I'm going to test on these two lines. So if you take this, you place it there, the answer you're going to get, you just write the sign. Don't write the answer as the whole. You write the sign of that same answer. So how are you supposed to be writing these numbers? If you get 0 here, you plug it there, you're going to get what? You're going to get 7, if I'm not mistaken. Why? I mean, why are you supposed to write a number only? It's because we want to come up with the overall sign at the end, which is this one. So if you get 0, you place it there, you're going to get what? Positive, because this is positive 7. You get 0 here, you place it there, you're going to get what? Negative. You come in between here, you still do likewise by saying 3. You place it there, you're going to get -6 plus 7. This is going to give you plus. If you try to get 3, you place it where there is negative, where there is x in this expression, or rather this factor, you're going to get positive, because 3 minus 2 is positive. You come to 4. If you get 4, you place it here, you're going to get -8 plus 7. This is going to be negative, because you're going to get -1. Avoid writing numbers here. You only write the sign of that number you're going to get after testing by the numbers that are in the respective columns. You get 4 again here, you place it there, you're going to get negative. To get the overall sign, you multiply this multiplied by that, we are going to get negative. This multiplied by that, we are going to get positive. This multiplied by that, we are going to get sorry, here we made a mistake, because if you take 4, you place it here, we are going to get positive 1. Yes. Yeah, if you place 4 where there is where there is x in this expression, you say 4 minus 2, you are going to get a positive. Then you subtract this, you multiply this by that one, now you're going to get negative. Now, you have to make sure that if you're using less than or equal to or even a less than symbol, you only focus on the part that is giving you a negative as the overall sign, because less than or equal to, it only caters numbers that are less than what? 0. So if you get a negative as the overall sign, that is going to be part of your calculations or part of your solutions. If you get again another negative on a given part, this one is going to qualify to be a part of the solutions. But how do you write the same solutions? This actually means that our numbers are going to start from this given point, moving to the part where there is negative. Same applies even here. You move from here, going to the part where there is negative. Remember, initially I've used unshaded bubbles. Why? Because I want to identify which one is going to carry a shaded bubble and which one I should ignore. So if you get back to this, we have something like this. Okay, we have something like this. We are having negative 2x plus 7 over x minus 2. I say this, you shouldn't be considering to be part of your what? Your solutions. Why? Because it is a denominator. We are saying x has to be equal to what? 2. So if you're writing using intervals or maybe range or domain, whichever, you have to make sure that x shouldn't be equal to 2. Why? Because if you say x is equal to 2, you're almost making this one to be undefined. That is if you're writing your what? Whenever you're trying to write for intervals and also for domain. But when finding the critical points, you just equate everything to 0. Once you equate everything to 0, you're going to get the critical points. But when it comes to writing the so-called intervals, you ignore the denominator. No matter how many denominators you're having, if you have 2 here, both of these two are not part of the solutions. Why? Because if you equate, if you say x plus 1 equal to 0 or plus 2 to say, then x is equal to -2. You consider this entire thing to be part of your solutions. You put it here, you're going to get 0. 0 multiplied by everything, you're going to get 0 on the denominator. That's why all the denominators always carries smooth brackets and unshaded bubble. You come back to this. What you're going to understand the most here is this one is going to carry an unshaded bubble. That one is going to carry a shaded bubble. Why? Because this is a denominator. We are saying it shouldn't be considered to be part of our calculations. This one is going to be like this. Meaning that from here going to negative infinity, where it ends, we call it my infinities. So you are going to write your numbers like this now. You say negative infinity. You start with what is on your left-hand side. Please start with what is on your left-hand side. We don't start with the number which is in front. No. You start with what is on your left-hand side, where it is going. Same applies even here. We are starting from here, going to that side. I can't start from positive infinity and then I'll end here. No. I have to start from where? From this point, moving towards the positive infinity. Here I'm moving from this side, going to my right hand side. You say comma. You put this number now because it is the one which is along this comma line. That's where you're starting from. Say 2. Then you come to this given part. What number is here? We are saying it has to be 7 over 2, comma what? Comma positive infinity. How do you combine this? For less than, you have to use what we call intersection. But when combining, you can't use this one. And most of the times, we normally combine using the so-called union to combine two different solutions on this part and also the solutions on that given part. Why do I point it in that direction? It's because I'm following the negative side, which is less than 0. Same applies even here. The overall sign here, it has been given as what? Negative, negative sign. So how do you combine? We are saying this shouldn't be part of our solutions, meaning that it is going to carry what? Smooth bracket. In the beginning or in the second, I think it has to be the first document that I made. I said all the infinities, they must carry smooth brackets. Why? Because they don't have a specific number. Same applies even for this one. I'll use a smooth bracket. If you come on this one, since this is a numerator and also we are using this symbol, automatically it is going to carry square bracket. Reason being, it is part of the solutions now. So this is the first thing you have to understand the most. And this caters for the first sign graph. You got the second sign graph and look again at what is going to happen to the second graph using the second critical values. What is the set of the second critical values? We had x equal to 5 over 4 and also x equal to 2, meaning that this number has to be less than that. So this is going to start, then you are going to have that one. Okay, you draw a sign graph again. Bam. Here what it is, we remove all the laziness you are having. If you are the laziness in terms of writing what we call linear programming, what, statistics, all those stuff, here that laziness is going to come to an end. Yeah. Bam. Bam. If you have two different factors, or rather if you have two critical points, you have to write how many lines? 3 of them. This one for the first critical point, that one for the second. Then this one demarcates where the range is going to be for this number and the numbers, or rather the factors you have to use. Okay, we proceed. Now, what expression did we get on the part of the numerator? We got something like negative 4x plus 5. What about the denominator? We got x minus 2. So here I won't even be explaining as that much because you already know what we have to do now. In the middle, we're going to write 5 over 4 less than x less than 2. X here has to be greater than 2. That side we say x must be less than 5 over 4. Why do we write these things? It's because they show us the numbers you're supposed to pick. We don't use this number. You pick the number which is before that and the numbers in between, the numbers above. You test. So here, if you pick the numbers before this one, this, if you divide this into that, what answer are you going to get? This is just one and the same, like 1.25, of which if you want to get a number which is before 1.25, what number can you get? I'll just get 1. I pick 1. Here I'll use 1. In the middle, what number can I get? 1.25. What other number can you get which is in between? You can even use 1.5, because 1.5 is greater than 1.25. Yes. Here we can pick 3. I'll start. 1 here, you're going to get -4 plus 5. What sign are you going to get here? Positive. 1 there, we're going to get 1 minus 2, we're going to get negative. You get this. If you multiply 1.5 multiplied by 4, this is just one and the same, like you are multiplying 4 multiplied by 3 over 2. You cancel 1, you cancel 2. This and that one, we are going to get 6. Meaning that if you place 1.5 at this given point, you're going to get -6. -6 plus that one, we're going to get negative. If you try to get this same number, you place it here. It's more like you are saying, okay, 1.5 minus 2. What will be the answer? Automatically, you're going to get -0.5, which is negative. You get 3 here, you place it there. -4 multiplied by 3, this is -12. Plus that one, going to get negative. 3 here, we're going to get positive. The overall sign here, overall sign, you have to focus on the part that is going to give you negative as the entire sign. This multiplied by that, negative. This and that, positive. This and that, negative. We are moving from here, going to the part of the negative. If we had greater than, I would have focused on the part of the positive, which is the middle part, just like this. As simple as that. Go to the part which is going to be part of the solutions. We are saying only the numerator has to be part of the solutions. The thing is very simple here. You come here, numerator is this one. This is going to be part of the solutions. This one won't be part of the solutions. That actually means that I'll shade this bubble and not this one. Why? Because 2 is not part of the solutions. It is a denominator. How are we going to write? We start from -infinity as usual, ending up to 5 over 4. And this has to be part of the solutions. Union, open, you say 2, comma, positive infinity. Now, how do you combine? How do you combine? How do you combine? What you're going to observe is this. This number which is here is less than 2. This number which is here is less than that. Meaning that 2 has to be in between. Why? Because we're going to start with this number ending up to that number. What I mean is this. This one, since it is less than 2, it has to start. You're going to write it from here up. So 5 over 4. You come to this number which is here. If you check, this number is greater than the 2 which is on this given part. What are you supposed to do? Meaning that this 2 has to be between this and that one. Here you're going to write 7 over 2. You put a union in between. The remaining numbers, I think you know them already. Comma, positive infinite, comma, negative infinite. You put something like this. This one is carrying square bracket. That one is also carrying square bracket. This carries it has to carry smooth bracket. This qualifies to be our answer. You get your 5 marks. As simple as that. Before you even ask your question, let me handle the next type of a question, which requires us to have a full understanding under the so-called double modulus. What are you supposed to do if you're having double modulus? Are you supposed to include positive or minus, something like that? If you're having double modulus, we're going to look at that right now. So I'm saying, example 2, Remember what I said. If you are having double modulus and then the other modulus is having a negative, no solution for that same expression, because you can't get a negative number then you equate it to a number which is under modulus. No, I explained for under that same concept earlier before. So we're going to have example 2. What is it that example 2 is trying to tell us? What is it that example 2 is trying to tell us? Okay, so we can say solve for modulus. We're going to have 3x plus 2 here, close. Then you put less than or equal to modulus. We say x minus 1, close. Things are very simple, guys. Perceive are very simple if you are studying. If you are studying. Here, no time of wasting like, hey, what? Yeah, time is there for you to even relax, like you watch football, you watch my movies, what. If you want, you can't even be attending lecturers. No one will even ask you to say, why aren't you going for classes? No one is going to ask you. But what you have to know, you have a credit from higher education. Very, very important. That is a ringtone. So, guys, this expression, if it has come like this, don't even stress yourself. The best way to handle this one is to do what? You square both sides. Because if you want to introduce a positive or minus on this one, same applies even on this one, you're going to do likewise, of which you're going to waste much time as compared to if you square on both sides, you get two different values only, and you come up with the sign graph, you get the solutions. Simple as that. So you square both sides. How do you square? You have something like this. Here, what the way you're going to write it now, it has to be something like this. Say less than or equal to x minus 1. You square. If you square here, what answer are you going to get? Squaring on both sides is it means you have to come up with something like this. Less than or equal to x minus 1. X minus 1. Simple. Not ways, I don't understand. I think today you are able to get the kind of simple concept that we are trying to. Yeah. So what next? You multiply this, multiply by that, this multiply. In short, you start from the left hand side and you know how to multiply these numbers. This multiply by that, this multiply by that. So if I say this multiply by that, I'm going to get 9x square. This and that one, I'll get 6x. This and that, I'll get 6x. This and that, I'll get 4. I'll say less than or equal to. This and that, I'll get x square minus this and that, I'll get x. This and that, x plus 1. Okay, so 9x square. This plus that, we're going to get 12x plus 4. Okay, less than or equal to x square minus 2x plus 1. Please, if you reach at this given point, guys, make these numbers move to the other side. Not to Mongolo, you start even, you like. So here what I'll do, I'll put 0 here, then less than or equal to that. Then this I'll get it to this. No. Take it on the low. Just move these numbers to this other side. As simple as that, the job is done. We're going to have 9x square. If you take this to this side, you're going to get negative x square plus 12. Remember, we are adding the correspondings. Then negative 2x, you take it that side, you're going to have 2x. Here you write plus 4. If you take this to the other side, simple. This minus that, 8x square. This plus that, 14x. This and that, 3 less than or equal to 0. Ignore about this part first. I'm saying ignore about that part. Why? Because you want to find the so-called critical points. As simple as that. All right. Okay. So the thing is, here to find the critical points, you have to equate the entire expression to what? To 0. So someone might be asking to say, how do you solve that one? This is what we call a simple factorization. Simple, just factorize. In grade 10, we learned about this, that is term 2. If you didn't learn this in term, that is term 1. If you didn't learn about this in term 1, then it was taught in term 2. If you didn't learn about this again, then go back to the books. Otherwise, we are going to do it like this. You just have to know the products. If you multiply this and that, you are going to have 24. You have to know the sum, the numbers that you are going to get or that you are going to add to give you 14. So here, first of all, you have sum, then factors. What are the factors? The product, if you multiply this and that, we are saying 24. What two numbers, if you add, they should give you this. If you multiply, you're going to get that. Simple. You're going to get the so-called 6. Sorry. Here we're going to get 2 and 12. If I add these two, I'll get 14. I multiply them, I'll get 24. Simple as that. Okay, so I'll put them where there is in the expression, which is this 2x, 12x, 0. So here factorize this part and also factorize that part. You're going to have 2x open 4x plus 1 plus 3, 4x plus 1, equate everything to 0. You're going to have 2x plus 3, 4x plus 1. Remember, this is a linear type of inequality. Remember, this is a linear type of inequality. We've tried to forget about this part just for a while, just a bit. We're going to get back to it because it will help us find the so-called intervals. So I'll equate everything to 0. 2x plus 3 equal to 0. X in this case is going to be negative 3 over 2. 4x plus 1 equal to 0. X is going to be equal to negative 1 over 4. Simple. This number is less than that. Oh, sorry. This number is less than that because if you are moving from negative going to positive, the numbers that are just closer to 0 are much better or are greater than the numbers that are far away from 0 on the part of the negative. Hope that point is clear. Okay. In terms of writing, you have to be very quickly. You have to be doing it quickly. Quickly. All right. Focus on the part of what we call. Hey, where is the rule? Okay. Like I'm very, very happy. Don't know why. We have two different critical values here. We are going to have 3 vertical lines. Bam, bam. Bam, bam, bam. Okay. Okay. What critical values are we from getting? We got x as equal to negative 3 over 2, which is less than negative 1 over 4. We are going to start with negative 3 over 2 and negative 1 over 4. Here we get x negative 3 over 2 less than x less than negative 1 over 4. That is the middle part. Here we get to mobile. Why moving you? Okay. Here I'll get negative, x has to be less than negative 3 over 2. Remember to put the critical, or rather to say the factors. What do I mean when I say factors? I mean these. That is 3 and also 4x plus 1. Overall sign. Okay. Right. What number can you pick that is before this? This is just one and the same like negative 1.5, meaning that I can put negative 2 before this. In between here, what number can you get? Okay, so we're having negative 1.5. Okay, we are having negative 1.5, meaning that in between, if this is negative 1.5, this one is going to be negative 0.25. What number can you get in between? You can just get negative 0.3. Simple. Negative 0.3 in between, or negative 0.4. Negative 0.4. Or if you want, you can even get negative 1. To simplify things, get negative 1 here. Because here we're moving towards the negative. That's why the numbers keeps on what? Reducing. We don't say they're increasing because we're moving towards the negative. Hence they are increasing. So here I'll get negative 2, negative 1. Here I can just get 0. Simple as that. You take this and replace it there. 2 multiplied by negative 2, we are going to get negative 4. Plus that, negative 1, negative sign. This, you put it there, you're going to get negative 8 plus that, negative sign. Negative 1, you put it there, we're going to get negative 2 plus 3, we're going to get, that is positive. Negative 1, you take it there, we're going to get negative 4 plus 1, that is negative. You get 0, you put it there, we're going to get 0 plus 3, that is going to be positive. And also, same applies on that given part, positive. Do we have anything which is a denominator in this case? The answer is no, meaning that all these two answers are going to be our answers, part of the solution. Why? Because nothing can disturb our calculations. Overall sign, this multiplied by that, plus this and that, minus, plus. Focus on the part that is giving you a negative. Focus on the part that is giving you a negative. In this case, the part that is giving us the overall sign as a negative is this part. Okay, remember, we're saying both of these two critical points are going to be part of the solutions because we don't have a denominator here which can disturb us. You can only get these two not to be part of the solutions by using smooth brackets if they used, for instance, if they used a sign of less than only. So since we are using this sign less than or equal to, this shows that you have to use square brackets and shaded bubbles. Simple. If you didn't do the first document I sent, get back to it. You understand it fully, clearly. Okay, so we have negative 3 over 2, comma, negative 1 over 4. Why do I focus on this? That's where the arrows are pointing. These two numbers, they all have, in short, all the numbers in between, they gave us a negative. Square, simple. The last thing that we're going to look at today has to be roots of functions. Can you try to write this point down? If you have an even root, you always equate the numbers or function under the root to greater than or equal to 0 when finding the domain. What does it mean? Suppose we have this expression. This is an even root. The meaning of even, it means this root is okay, in short, it is in a form of an even root. It can be something like this. See, you can have a 4 here, you can have a 6 there, all those numbers. If you have such kind of roots, suppose we have x plus a over x plus b. You want to get, or you want to find the inequality for this one. Just equate it to what? To greater than or equal to 0. That is if you're having an even root. This one is also an even root. Why? Because everything under the root, like x plus 1 over x minus 1, you can raise them to 1 over 2. We don't write numbers like 1 over 2 and then you write like this. This is a wrong way of writing numbers or expressions. You can't put a 2 here. Meanwhile, this automatically already shows that this is a square root. You don't write like that. So if you're having an even root, you want to find the domain. The domain can only be found using the same way we are from using. So meaning that here, for you to remove the square root, you just write like this. Simple. And you know what to take for you to come up with the critical points and the like, and how to find the so-called values, and how to draw on the sign graph. You know how to draw this. Just equate this to 0, that one to 0, you find the critical points. This sign means that you're going to focus on the overall sign, which is going to be positive. Remember the denominator, always avoid making it to be part of your solutions. You're going to use a smooth bracket or a smooth, or rather unshaded bubble. The other point you have to know, if you have odd root, to get the domain, you just have to say x is a member of all real values. Simple. If you're having an odd root, the meaning of odd root, you can have something like this: 3 here, and you have x plus 1, x minus 1. No need of equating to greater than, less than, no. Just say it has to give you all the values of x must be part of real numbers, or they're going to be members of what? A real number. Example. I'll just give you an example on the part of the so-called even root, because for odd root, it's very rare for you to be asked question under odd root. Okay. I'm doing this quickly because I'm looking at the time that this kind of thing is taking. Once it cuts for an hour, then the video has to be cut. That's what it works like. I mean, like the video that I'm making here is going to stop unless if I restart it. Okay, so the example can be like this. Solve for, then they say root of x. I can put maybe plus 2 here over x minus 1. If you see something like this in your paper, or maybe wherever you see something like this, smile. This is very simple. First of all, what you have to do, this is an even root, because it doesn't have any. If they put 10, that is even, 20, that is even. Still, what you have to do, you equate everything to greater than or equal to 0, meaning that you're going to do it like this. Critical points, equate this to 0, equate that to 0, you're going to get the critical points. So x plus 1 plus 2, has to be equal to 0. X minus 1 has to be equal to 0, meaning that x is going to be equal to -2. X is going to be equal to 1. Sign graph. Okay. Look at the sign we are using. greater than or equal to, we focus on the part of a positive overall sign. That's the rule. So here we are going to have -2. That side we're going to have 1. Okay. Okay. All right. So definitely we have the critical points here. I mean the factors. What number can you get here? We can get -3. In between these two numbers, 0. That side, 2. Simple. Don't even stress yourself. Wait, what? Okay, if you get -3, you put it there, you're going to get negative. -3, you put it there, negative. 0, you put it there, positive. 0, you put it there, negative. 2, you take it there, positive. 2, you take it that side, positive. Overall sign, that multiplied by that, positive. This multiplied by that, negative. This multiplied by that, positive. You focus on the part depending on these two. This one is going to be nullified. It won't be part of the solutions because it is giving us a negative. We can't say negative. I mean, it is giving us a fraction. I mean, it is giving us the expression to be what? Undefined. So you focus on the part of positive. Even here, you also focus on the part of positive. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. So you start from negative infinity, ending up to -2. This has to be part of the solution. This one not. Union, open. Use smooth bracket for this one because it is not part of the solutions. 1 up to positive infinity. This is all what I prepared for you guys as for today.